Hi and welcome back. Tonight's notes are on page 60. And this is going to be a review from Integrated 1. It's going to be inequalities. And absolute value inequalities. So you did learn this in Integrated 1, but now we're going to move on using quadratics with inequalities. So tonight I just want to do a quick review about how to solve inequalities and how to solve absolute value inequalities. So first off, the inequality symbols. We have 4. This one. Those 4 are our inequality symbols. This says less than. This says greater than. This says less than or equal to. Because of that little line down there. And this says greater than or equal to. Okay, so those are our symbols. Now, we're going to start off with an example. And we are going to solve the inequality. Five x plus 4 is less than 19. 5x plus 4, and that symbol is our less than symbol, 19. So maybe you remember from Integrated 1, but we do 3 steps to solve these. Whenever you see an inequality symbol, your brain should say 3 steps, because we have to do 3 steps to solve it. So our step 1 is going to be to make it equal. That means instead of a less than symbol, we're going to make it an equal sign. So that'll be 5x plus 4 equals 19. And then you know how to solve that. We're going to subtract 4. So x equals 3. Okay, that number gets put on a number line. So we make a number line. And we just put that 3 on the number line. Okay. Step 2, open or closed. We have to answer that question. Now, hopefully you remember inequalities. They could be equal to or they could be not equal to. And on this number line, you either have to put an open circle or a closed circle on that value. That's determined by what sign this is. So since this is a less than sign, it is going to be an open circle. So I'm going to go, this is an open circle, and then on my 3, I'm going to put an open circle here. Okay? Now, how we know which ones are open and closed, this is going to be the less than and the greater than symbol. These 2 are open circles. And the ones with equal to, those are closed circles. And then our third step is going to be to do a test point. And it could be any point on this line besides the number that we already have on there. I always like to do x equals 0 if that's not my value. We're going to plug that into our original inequality and see if it's true. So that'll be 5 times 0 plus 4 is less than 19. 0 plus 4 is less than 19, which means 4 is less than 19. Is 4 less than 19? That's what we have to ask ourselves. 4 is less than 19. Yes, that is true. So on our number line, we put our, so if 3 is here, 0 will be here. And you just told me that it is true. That means that we shade in that direction. Now, if it was not true, you would shade away from that point. So now we have our number line, and then our final answer is to write it as an inequality. So looking at this, we write x, and is this less than 3 or greater than 3? It's less than 3. That's our answer. Your answer for an inequality includes inequality, this guy, and the number line. You need to have both. Okay, so that's how to solve a just an inequality. Now I'm going to have you do one. So go ahead and solve this next one. Okay, solve 3x minus 7 is greater than or equal to 20. So we're going to go through our 3 steps. Step 1 will be to make it equal. So we're going to do 3x minus 7 equals 20. Add 7. 3x equals 27, which means x equals 9. That gets put on my number line. Step 2. Open or closed. Looking at this symbol, we have an equal sign, so it is going to be a closed circle, which means I just go like that. And then step 3 is test point, x equals 0. 3 times 0 minus 7 is greater than or equal to 20. That'll be 0 minus 7 is greater than or equal to 20. Negative 7 is greater than or equal to 20. Is negative 7 greater than or equal to 20? No, that is not true. So 0 is over here, and this is not true, which means we shade the opposite direction of that 0. So our answer is x is greater than or equal to 9. All right? So that's just solving basic inequalities. Now we're going to move on to solving absolute value inequalities. Okay? And it doesn't change a lot. So we're going to go ahead and solve this next example. The absolute value of x plus 6 is greater than 11. Okay, so now we have the absolute value symbol and we have an inequality symbol. Again, whenever you see that inequality symbol, your brain says 3 steps. So you continue to do those 3 steps. They just change slightly. So 3 steps. Our step 1 is the same, make it equal. So that means we're going to have now the absolute value of x plus 6 equals 11. Okay, now this is the only change. When you have to solve an absolute value equation, you set up 2 equations. So what that means is you're going to go like this, and you're going to just take the inside, x plus 6 equals 11, But then we know things about absolute value. If this inside equals 11, the absolute value of it is going to be 11. But what else could this inside equal to make the absolute value 11? It could also equal negative 11, right? Because the absolute value of negative 11 is positive 11 as well. Then you solve both of those. Oh, sorry. There we go. So x equals 5. And x equals negative 17. Okay, now you put both of those on the number line. So I'm going to have my number line. And we put both of those values, negative 17, 5. Okay, we put both of those values on the number line. Step 2 is the exact same. Open or closed. So it's going to be the same for both. So looking at this, we have a less than symbol. So we're going to use an open circle. And it is an open circle on both. It's always going to be the same, either open or closed on both. And then the third step is going to be test points. So before it was test point, we only had to do 1. Now we have to do 3 because we have this section over here, the section in the middle, and this section outside that we have to test. So you have to choose 3 test points, okay? So let's choose that's out here. A number out here could be, let's say, negative 20. So I'm going to test x equals negative 20 to start. So that'll be the absolute value of negative 20 plus 6 is greater than 11. The absolute value of negative 14 is greater than 11. 14 is greater than 11. Is that true? Yes, that is true. So out here, this is true, which means I'm shading this way, for sure. Then I need to test the middle. Well, a good point to choose in the middle would be 0. So now I want you to go ahead and test 0 and tell me if it's true or not true. So when you test 0, that'll be the absolute value of 0 plus 6 is greater than 11. That'll be 6 is greater than 11. Is that true? No. Not true. So we do not shade there. And then on the other outside, let's go ahead and test 10. And you tell me if x equals 10 works. That'll be the absolute value of 10 plus 6 equals, is greater than 11. So 6 is greater than 11, which again is true. So out here is true as well, which means we shade that direction too. Okay? Now, the hard part with absolute value is you have to determine how to write your inequality. At the beginning, all we had to do was write 1. Well, now we actually have 2 to write. We have this one, so I like to cover it up. Right here. Is this part less than or greater than negative 17? It's going to be less than. So we have x is less than negative 17. And then this one, that's going to be x is greater than 5. And then it's either one. You could be over here or you could be over here. So we write an or in between those. Okay? If it was the middle part, you would write an and because it's just the middle. All right? And your teacher will do more examples of that in class tomorrow. Thanks for watching.